All right, good morning. And let's have some reminders here. Your programming test 1, we're definitely finishing grading it. You should be able to hear back from me by the end of this week, for sure. And then once you get your marks, you also get some detailed feedback about running the grading test. And if you got any concern, you can also submit some requests for regrading as well. So we definitely will handle that for you. All right, for lab number 2, we already released the solution video. I will also release the grading tests like lab number 1. So you can definitely get an idea about what the cases you actually have been missing from your implementation. And your exam has just been confirmed by the registrar office, just in case you haven't checked. You can just double check, but I checked just earlier. It's gonna be in person. The venue has not been confirmed, but I think given our size, it's hard to say. It might be in a lecture room like this, or it could be in the exam center. So as soon as I know, I will also let you know. Yes?
Is it written or is it?
Yes, it's going to be written, but maybe I'll talk about the format a little bit later. But usually, I can tell you, well, it's kind of the first time running the exam, after the lockdown. Most likely, it's going to be multiple choice combined with some written question as well. So I'll give you more information in the last week. But just for your information, it's going to be 7 p.m. to 10 p.m. I'm sorry, that's the way it's being set up by the registrar office. Make sure have enough sleep and also got some nice enough dinner before the exam. All right. Oh, we'll talk about it. Monday, December 12th is rather close to the last day of the class. It's only about 1 week. Usually, if you got 2 weeks, you might have some time to study. But this time, I will try to see if I can schedule maybe some review session. Maybe after your study day, we can just answer your question. We will see. Well, I'll keep you posted. For your written test number 2, if you look at the calendar, you can see starting from next week, we have our written test number 2 next Tuesday during the scheduled lab session. The format will be just the same as how we ran your written test number 1. And by the end of this coming Thursday, I'll give you some guide, which you can expect to be almost the same as last time. But I'll give you some practice questions as well, so you can definitely start studying. It's going to cover until lecture 13, which we will be covering on Wednesday. Right? I'll give you the precise range a little bit later. Okay? And also, we got programming test too. I'll also give you some practice question prior to it. All right? All right, that's about some reminder for you guys. And if no question, let's move on. All right, so let me give you a very quick recap about what we talked about last Wednesday. We introduced the idea about equality. And if you remember this important diagram over here, this really summarizes the spirits of the lecture. You have this so-called object class, which is the parent class or superclass of every class that might exist in either your projects or the Java API. And in the object class, there is this accessor called the equals method, which returns a Boolean. It has this very easy one-line definition, which we explained last time. For any class you define, if you do not explicitly define or override the equals method that's inherited, it's just going to use the default version, which we looked at last time. We even tried to step into the method call in the Eclipse to show to you. So you want to make sure you understand what's going on. And what we started discussing, but we haven't finished yet, was about how you can override the equals method if you want to. Most often, you actually want to override or redefine the version that's inherited from the object class. That's why the tricky thing is, whenever you see something that equals something else, you want to make sure you know which version of the equals method that will be called. We'll see lots of examples today once we finish the last bit of the equals method. Right? If you recall this definition here, it's a very standard definition. If you really prefer to rewrite it in a way you believe is equivalence, feel free to check with me. And you're not really forced to really write this particular definition in the lab or in the programming test. As long as it works, passing the test cases, you'll be okay. But at least that's a standard. We talk about 1, 2, and 3. These 3 phases we talked about in very much detail last time. If you got any doubts, you can refer to them. And today, we're going to start with this final phase. And after that, we're going to do lots of examples to show you. All right. Alrighty. Let's now move on to phase number 4. All right, for phase number 4, that means we can reach this particular block, right? So if you just recall from here, from here, and from here. Let me remind you just once more. Number one, we know that the argument objects is not equal to the current object. Since they are not equal to each other in terms of the address, we will bother to actually compare them. And number two, we know that the object is not equal to null, so that we can compare. If object happen to be null, it's trivially false for the equality. Number three is about checking the so-called dynamic type. And the way to check the get class return type is by looking at the title of the object box when you do the tracing, like what we said last time. And also we can say here, this, and the argument objects have the same dynamic type. Right? So we can compare apple with apple or banana with banana. Right? That's about the three phases. If you're able to reach this particular line for phase number 4, that means 1, 2, and 3, they're all satisfied. Right? That's basically where we were. And we want to now handle this block over here. The most important thing for you to notice is as follows. If you look back to the definition of the equals back in the object class over here, you can see the way we declare the parameter here is we declare that to be of object type. Right? As I mentioned last time, this is so-called a static type. And we'll talk more about static type once we start discussing the inheritance. Most likely it's going to happen either in the later part next Monday or maybe early, or we'll start with Wednesday. Either way, we'll start talking about inheritance. But for now, you can understand static type as follows. It is the declare type. Whatever type you declare the object to be or the variable to be, it can never be changed. That's why it's called static. Declare type. We declare obj to be of type objects. And what would be the consequence of declaring a particular static type? It's going to restrict about the methods you can call upon the objects. Now, let me finish this. I'll take a question. So this will restrict the range of methods callable on the object. So in this case, because in the object class, we didn't really declare attributes like x and y. So that means we cannot really directly say obj.x and obj.y. It's got to be a compilation error, which I showed to you last time. Right? Just remember, and I'll take your question just in a moment. So this means if you say obj.x or if you say obj.y, it's going to be compilation error. So we got to do something about it called typecasting. Yes, question.
I just really quickly ask, does static mean that it's still noun plus on not final static, but it's the same across all?
Okay. Good question. So here, don't really get confused. When I say static type, don't confuse it with the static keyword. Let me write it down explicitly. It has nothing to do with the static keywords that we spoke about before when we talk about static variable. Let me write it down explicitly. Nothing to do with the static keyword. Whenever we talk about the static type, it's really just about like a synonym to the declare type. Whatever type you declare the variable to be. And in Java, you cannot change the declare type of a variable once you declare that. And in other programming language, you may change that, like a Python, for example, is dynamic language. Anyway, so just to summarize, whenever we talk about static type, number one, don't get confused with this static keyword. They have nothing to do with each other. Number two, static type simply means the declare type, which will determine what methods you can call upon this particular object, meaning that, which will get more concrete later. For the same objects, depending on what the static type is for the particular variable that's pointing to the objects, you may call different range of methods. This might sound a little bit confusing at this moment, but that's something we have to know very well once we get into the inheritance. Okay? All right, any questions so far? We okay, right? Let me go a little bit deeper here. So we know that if you simply say here, obj.x, obj.y, we cannot do that. So what can we do over here? What I want you to want you to look at is this. Let's say, let me try to sketch some code over here. Let's say we have point v2. Let's say, I'll just say p3, which is a new object, point v2, and then with some value over here. And let's have another object over here, also point v2, p4, which is another new object over here, point v2, and then some value over here. Right? Let's say we want to compare whether or not these two variables are equal to each other using the equals method. Let's consider this line. I'm going to write it down. Let's say we got p3 dot equals p4. All right? And let's now focus more on p4 over here. All right, let me just visualize what's happening now, and then we'll introduce a complication. Let's visualize p3 and p4. So we basically got two objects over here. One is here. Another one is over here. Let's identify where p3 and p4 are. p3 is simply just one new object. Its content is not important at this point. And also we got p4, which is just another object, p3 and p4. That was straightforward. And one thing we're going to talk about, which is called a call by value, most likely is going to come on Wednesday. But for now, it's still easy for you to see. P4 over here is the arguments. OBJ over here is the parameter. This is the argument. And over here, OBJ over here is the parameter. So you can think about the way this will work is OBJ, the parameter, when we call this method, is going to point to wherever P4 is pointing to, OBJ. So when we try to do obj.x and obj.y, we said that you cannot do it because obj has a static type object, so you cannot do it. So you can, but if you look at the diagram here, obj indeed is pointing to some objects that supports x and y. So there's a trick we're going to do, which is called typecasting. Let me emphasize one more thing. And for the obj over here, its static type is objects. Just remember that's what we declare obj to be. The idea would be we want to treat the same objects, but with a different static type. As I said before, static type cannot be changed for the same variable. So what we have to do is to create another variable, more like an alias of the same variable, of the same objects. And then that variable has the more accommodating static type. That's what typecasting is about. Let me explain that here by using this line of code. If you look at this line of code over here, okay? Let's look at this part over here. When I say point v2, the cast, and then obj, we know that obj is already pointing to this object here. What does cast really mean? When I say I want to cast obj into point v2, that means I'm creating an alias like this. I'm creating this alias. Okay? This alias created by the cast. But it's very important to note, this alias over here has this particular static type. And this alias over here has a different static type, which is point v2. This will be the static type of the alias. So the static type will just be point v2. All right? And if you look at the entire variable assignment over here, the right-hand side of the cast creates the alias of a different static type. The left-hand side is trying to let other point to that particular objects. Right? So what we got is one more. That one there is going to be just other. And other is just going to point to just the same objects. I know you got many aliases over here, but that's just the way it works. Okay? And this, I got a little typo here. I'm going to fix it. So here, this type here should be point v2. Okay? And the other here is point v2. After we have done all these, I'm going to summarize at the end, but let me just finish that part. Once we have got this other, if you compare other and also obj, they are pointing to the same objects, number one. Okay? You can see other is pointing to this object here. Obj is also pointing to these objects. However, the difference is obj has static type objects. Other has the static type point v2 because we have done the proper casting. Now, are we able to call x and y on other? Yes, we are, because the static type has been changed by creating a new variable alias to the same objects. Any immediate question right now, before I try to recap a bit? Any part you find very confusing? Right? Everybody's okay? Let me recap, all right? Number one, obj here is of static type objects. So you cannot say obj.x, obj.y. You just cannot. The way to get around with it is to say, I'm going to create some alias pointing to the same objects, but that particular alias has a different declare or static type. That would be the idea. How can we do it? We have to somehow do a so-called typecasting over here. The typecasting here is obj is pointing to this particular object here. I'm creating an alias, which is called, which is by the typecast. And that static type is point v2. That's why you can see the point v2 is a new static type. And then I'm going to assign this new alias to other. So that's why ultimately you get other pointing to the same objects, but it has a static type. That's point v2. Once we have got this, remember I said before, the static type is going to restrict the range of methods that's callable on the variable. Now that other has the static type point v2 now, we will be able to call anything that's declared in point v2, including x and y. So that's why this will be OK. Let me just make a final remark, and then I'll take question from you. The other has the static type point v2. So x and y can be called upon it. It's tricky, the final phase. What we will dive deeper later once we talk about inheritance is to see why we will need to do casting. That's something we'll do. But I think it's a nice maybe summary about what things should happen. That's something you should know, at least for the written test too. All right? Any question before I move on? We are now basically done with the definition for the equals method. Now what we need to do now is to go over many examples just to make sure you're OK. No question? Everybody's OK? Yeah, think about it, and then review, and then come back to me, which is OK. So important to understand what this is doing and why we cannot just do obj.x and obj.y. All right, very good. Let's now move on. So what we need to do now is to do many examples to show to you how we can differentiate between the scenarios. Maybe in one case, we have to call the default version of the equals method. In another scenario, we have to call the overridden version from some class, right? That's something we'll see. All right, this is basically a written summary of what I just said. So you can maybe combine this slide with the visual I just did. All right, so this part here, we got reference equality, right, to compare addresses between reference type. And also we got object equality, we'll use the equals method. But for the equals method, whether or not it's overridden in the current class determines which version will be called. Just remember that, right? That's really something we keep emphasizing. And let's go over this example very quickly. I might just be able to show you a little bit of Eclipse, just to show to you. OK, we have different lines. I'm going to trace line by line. Let's now, first of all, to see what we got. The context is we got object class, we got equals, we got point v2, and also we got this overridden method, right? This is just a reminder. This is the overridden version. Overridden version, okay? And let's now trace line by line, okay? We got P1, P2, and P3. P1, P2, and P3. 2, 3, 2, 3, and 4, 6. Let's now write it down. So 2, 3, 2, 3, and 4, 6. One thing to tell you right away, you can easily see from the diagram. P1 and P2, even though their contents, namely the x and y coordinates, are the same, but they are different objects, different addresses. P2 and P3, definitely they are different objects. Their addresses are different. But more to it, you can see their contents, 2, 3 versus 4, 6, they're also different, right? You got a different scenario. You want to think about whether they are the same objects, addresses-wise, and also whether they are the same objects content-wise. So these are two things you want to always remind yourself. Right, very easy to see. P1 equals to P2, false, right? Not the same objects. P2 equals to P3, also false, not the same objects. So these two should be very straightforward. And let's now trace line number 7, okay? Line number 7 here, we have to look at P1 dot equals P1. So P1 here, I want you to compare. Okay, let me just go right in the earlier lecture. If you recall from last Wednesday, here we got point V1, point V1, point V1. Also, we got P1 that equals P1. We actually got P1 that equals P1 in two scenarios. In both cases, they are a little bit different. Let's see. In this case, point V1 case, we know that because P1 is pointing to some point V1 objects. So that means the equals method should really come from the point V1 class. However, point V1 class does not override the equals method. That's why it's going to call the default version. So it will boil down into P1 equals P1, which will be just false. That's what we said last Wednesday. And what about now? We also got P1 equals P1. But now the P1's type has been changed to point V2, which does have some overridden version, right? And here you can see P1, the dynamic type, meaning that P1 is pointing to some objects of this particular type, is point V2. That means the version of equals in point V2 will be called. And I'm going to show to you step into maybe a little bit later. If you imagine you say step into this particular equals call, it is going to go into this particular version. All right? That's already a difference compared with what I just showed to you from last Wednesday. And if I go into this particular one, what's going to happen? Are we actually going to return true right away? In this case, we are. Because if you look at what's happening here, P1 is the context object, which will be this. And P1 over here, the arguments is going to replace objects, P1. So that means we got P1 equals P1. That's what it will boil down into. So we're just going to get return true. All right, so this will be the execution path for this particular line. Quick recap. In the case of point V2, we are going to get true when we say P1 dot equals P1 because of this line. In the case of point V1, example that we did last time, if you go back there, we also get true in this case, but for a different reason. Because in that case, we're actually calling the default version, which will boil down into P1 equals P1. So it's different, even though both cases they are true. So be ready, maybe either in the written test or maybe in your exam. I might just put these two versions side by side. Number one, I'll ask you what the output is. Of course, they should both be true. Number two, explain why in both cases it will return true. You should be able to tell. In one case, it called the version that's inherited from the object class. In the other version, it calls the overridden version. All right. All right, any questions so far about the first line number 7? Everybody's okay? All right. Well, I think maybe the written test number 2 next week will be a good push for you to really make sure you study exceptions and also object equality, right? These are the 2 main topics you want to study for written test 2. All right, let's go on, move on. What about line number 8? If I say P1 dot equals null, all right, this kind of interesting case. Again, P1 over here is of type point v2, so we call this version here. So P1 is going to be this, P1, and obj is going to be null. So P1 equals null is going to be false. So we don't really execute return true right away. We don't. Right? You can think about this part here is going to be bypassed. So we don't really execute it. And when we get to this line over here, obj equals null. Indeed. So we're going to return false in this case. All right? So that would be the execution path. The reason I really try to be careful about tracing each line is you want to know which line is being executed to return the true or false accordingly. Right? So this line here is going to be false. Reason I just explained. So this one should be straightforward, right? Hopefully. All right, next line. This one here, P1 dot equals S, which is a string. We're basically comparing apple with banana. It's going to be false for sure, but you want to know which line is going to return false, right? Let's see. So we have P1 dot equals S. So every occurrence of this is going to be replaced by P1. Every occurrence of obj is going to be replaced by S. All right, let's now take a look. For this line here, P1 equals S. They're different objects for sure. One is a string, the other one is a point v2. No brainer. So we don't execute a branch. What about this line here? Obj equals null? Not really, because you can see S is indeed referring to some string object. So it is not null. So we're also going to bypass that particular line. What about this line here? If you look at that, that line is going to be executed because if you look at that, P1.getClass is going to give you this. This will be the value for P1.getClass. Just point v2. It's dynamic type. What about S.getClass? S is simply just a string at the runtime, right? So S.getClass is just going to give you the string, being its dynamic type. So string is not point v2. So it's going to be true for this inequality. So it's going to return false. So that's why you're going to get false here. Are we okay so far? So all the lines gradually shows to you how each phase may be executed to return the true or false. So far, it's the trivial cases to be true or false. What we need to do now is to look at the final case carefully. All right? Let's take a look. Line number 10, which would be here. Okay? We want to do P1 dot equals P2. All right? So P1 is a context object, point v2, dynamically. So we're going to call the overridden version. Okay? And P2 is actually over here. Okay? Every occurrence of this will be replaced by P1. P1 here, P1 here, P1 here, and also P1 here. Every occurrence of P2 is going to be, every occurrence of obj will be replaced by P2, and P2, and also P2, and also, oh, that's good enough. Okay, P1 and P2. All right, let's now trace it quickly. P1 equals P2. They are different objects, so bypass. We don't return true right away. What about this one here? I forgot to put it. Let me put it right away. So obj replaced by P2. Okay. So P2 now, not true, right? So we also bypass that particular line. So we don't really return false right away. What about this line over here? So P1 that get class and P2 that get class. P1 that get class will be this. P2 that get class will be this. These are the same types to be compared. So that means this inequality here is going to be false. So we don't return false. We are really comparing apple with apple. Finally, we're going to do this, which we just spoke about 10 minutes ago. Right? Let's execute this block, the phase number 4. And let me now do that carefully. How do we do this part here? Okay, and one more replacement, which I forgot to do. Obj, don't forget, is going to be replaced by the argument P2. This cast over here, you can rewatch the recording if you got any doubts. This one here basically is to say the following. If you think about obj has been replaced by P2. However, obj was declared to be of static type objects. So you just cannot say obj.x, obj.y. Instead, what we want to do is create an alias called other with a different static type. All right? So what we do is we're going to have an alias over here called other to the same objects, but its static type has now been declared as point v2. Again, it's a typo which I will fix. Point v2. All right? That's this line. And then we simply do p1.x, other.x. p1.x will be here, and then other.x is going to be here. And if you look at the initial setup over here, let me just show to you. It's 2, 3, 2, 3, and 4, 6. Right? Let's do it again. p1.x over here, other.x. Other is pointing to this object here, the x, 2 and 2. p1.y, 3, other.y, 3. They're the same. So that's why this line here is going to return true. We okay? This might be the most relevant part to what we just discussed in the beginning of today's class. But of course, make sure you're okay so far. Okay, a final line, which will be very similar. The final line, we are now trying to do P2 that equals P3. We're going to do very similar comparison. Let me do a little bit faster. P2, the context objects, is pointing to point V2 objects. That means we're going to, again, try to trace this equals method that's being overridden. And then we're going to reach this particular block, phase number 4. For the same reason as I explained for this line. It will be the same, right? Let's skip that part, okay, since we already talked about it. So now, how do we understand this part here? Still, we're going to have obj pointing to, in this case, P3 will be the obj, right? So obj is going to be P3. So let me just move this a bit. So just make sure I don't confuse you. Obj here is pointing to P3, but it's declared to be objects. So what we want to do is to create an alias called other. So other also pointing to the same objects, but its type would be point v2. The static type, right? Don't forget, it's a static type. Now in this case, we're going to say this.x, p2.x. Oh, let me also fill out the value. 2, 3, 2, 3, 4, 6. 2, 3, 2, 3, 4, 6. So now this.x, p2.x, 2. Other.x, which will be other.x, 2 versus 4, they are not equal to each other. So it's already false. Right? So this line here, line number 10, we're comparing P2 and P3. Their contents are not the same. And this last line over here, we're comparing P2 and P3. In this case, their contents, I'm pretty sure I said something wrong. When we compare P1 and P2 over here, their contents are the same. And when we compare P2 and P3, their contents are not the same. That's why it's going to return false. But we're still executing phase number 4 code. All right, any question about the lines we have discussed? This one here. Yes, please. Yes, it is an AND operator. Yes, I agree. Yeah, that's a very good question here. I was being a little bit lazy, which is okay. It's logically sound to be lazy here. I tell you why. Let's look at this part here again. It's a conjunction. It's an AND. So when I compare this .x, which will be P2.x, and also other.x, which will be here. So 2 and 4 is already going to make this false, right? Let's write it down explicitly. It's already false. For AND, if I know the left-hand side is already false, logically speaking, do I need to worry about what the right-hand side is? I don't need to. That's why I just said it's going to be false. But you're right. If you really want to, you can also compare this one, which will turn out to be also false. 3 versus 6, that's also false. So that's why the result will be false. And this will bring up some interesting topic, which I would like to review also today, a little bit later, which is called short circuit. I'll get there a little bit later. Good. All right, guys, any question? Do expect something like this in the test and in the exam. I might just give you different versions of the classes. Maybe some of them will override the equals method. Some of them wouldn't. And then I'll give you some test code, either console code, or maybe like a print line code, or maybe JUnit assertion. And then you're going to figure out what's going to happen. Yes?
This isn't really a related question, it's just a programming question in general.
Yeah.
Java.
Yes.
So if I have a conditional statement, I use the AND operator. Is the first condition in the conditional statement executed, and then does it branch off to, does it branch off if it's false?
Yes, it's a very good question. If you don't mind, let me delay my response. Maybe 15 or 20 minutes later, talk about it explicitly. I do have some notes. Yeah. Yeah, the question was about the conjunction and also disjunction as well. We'll talk about it for sure. Yes. All right, guys, any question I can help at this point? Everybody's okay? Okay. All right, and then I would like to do a very quick comparison. Let me go back to Eclipse. Okay, this one you can also try yourself to confirm. Let me see. Okay, my Eclipse is here. And let me show to you. Okay, that's the code I made available to you. And if you go to the pointtester.java, all right. Now, what I want to show you is we are indeed calling the overridden version. If you recall from last Wednesday, you can check the recording. When we declare P1 to be point v1, let's say, which does not have the overridden version, just default version. And when we try to say P1.equals P2, if you remember, I step into this particular method call, it will go into the object.equals method, right? That's one version, default version. Now I'm going to do the next one. Let's say we got P3 and P4. Specifically, P3, the context objects, is going to be a point v2 objects. Now, if I put a breakpoint in line number 43 here, when I say P3.equals P4, and I say step into, which version of the equals method am I going to see? The default one for object class or the overridden one? Should be the overridden one, right? Because that's where we declare the overridden version. Let's take a look. That's something I want to confirm together with you. Run the debugger, and then switch. Okay? And quick reminder, P3 is the context objects, and P3 indeed is pointing to some point v2 objects, right? And if I say step into over here, is going to switch the context into point v2. And then you can see that's the equals method we have overridden in the point v2 class. And then you can step over to trace. That's the main thing to notice. You want to compare this tracing here with the only tracing we did on last Wednesday. Right? That's the main thing I want to highlight. All right. Okay, let's now do more examples, okay? And one more thing I want to highlight, which I already said. If you put these two classes side by side, point v1 and point v2, and then we got the code we traced last time and the code we just traced. And then you can see p1.equals p2 versus p1.equals p2, all right? You can see in these two cases, we got false here, and we got true over here, right? If you compare these two, I'll just highlight the execution path, and then you're going to figure out, just want to make sure you're convinced yourself, right? Let's do that. Let's do the first one. Why is this one returning false? This one here, we are calling, according to P1, we're calling this point v1 version, which does not overwrite, so we're going to call this version over here. In that case, you will boil down into P1 equals P2, which will be false, number one. All right, number two. Let's take a look at this line. And when we say P1 and also P2, because P1 is now, according to it, it points to the point v2 objects. In that case, we're going to call this overridden version. And then P1.equals P2, it turns out we're going to compare this particular expression. So P1, if you look at that, P1 and P2, you can see their contents are the same. So that's why it's going to return true. Right? You can definitely do the visualization yourself, which we did already when we did the previous tracing. But putting these two side by side will be very useful for you to see which version being called determines the result, for sure. All right? Quick comparison for you. And then let me do just one more, and then we'll take a little break by taking attendance. Okay, just get ready. Okay, just do one more. Okay, let's take a look. Maybe also some important stuff to talk about. Okay, good. That's the one I want to talk about quickly. Okay, good. All right, let's say we got this. We got P1, P2, P3. Okay, let's now fill out the value. 3, 4, 3, 4, 4, 5. 3, 4, 3, 4, and 4, 5. And easy. P1 equals P1, definitely true. That one's easy. And what about P1.equals P1? First of all, true or false? True. Guys, actually, whenever you say some object that equals to itself, you can always say it's a no-brainer. It should be true. However, it depends on which version of the equals method that's being called, right? Now, can somebody tell me, well, it's already visual hints, very obvious. At least tell me, am I calling the equals here the default version that's inherited from objects or the overridden version? Overridden, thank you, because you can see P1 here, point V2, right? Just get more natural to yourself before next Tuesday. Right? So this one here is just going to be true because it's going to be boiled down into this particular line. Okay? And also we got P1 equals P2, no-brainer. They're different objects. False. And what about P1.equals P2? True, thank you, because you can see they have the same content, which we talk about. There's a reason for me to repeat this, but I will explain that. So this one here is simply just going to execute this part here, for sure. And finally, P2 equals to P3. They're different objects, for sure. But what about P2.equals P3? False, because they're different content, right? Let me try to ask you the following, right? So this one here is also going to execute this part here, but it's going to give you false. Now, here's my question for you. Let's consider two statements here. A, let's say two objects are reference equal. When I say reference equal, I meant they store the same address. For example, P1 and P2, they don't store the same address. But if I got another alias, let's say P4, P4 and P1 would store the same address, right? That's what A really means. And B, two objects are contents equal. When I say contents equal, I really meant this phase number 4 to define what it means for 2 points V2 object to be content equal. The X and Y coordinates must be the same, right? So this would be statement B. Now, I got two options for you. One and two. Let's read it together. If A is true, then B is true. If B is true, then A is true. Now, let's say it's a multiple choice question for your written test number 2. Which one is true? Which one holds, or both, or neither? Think about it. And you can definitely use the example we just showed to you to justify. Yeah, we got 2 already thought it through. Okay. Marcus, I'll let you speak, please.
I think it is 1.
Okay.
Because if 2 objects are reference equal, then that means their contents or 2 objects with their contents would be equal. Because if you look at the example that we just did,
Yep.
you know that P1 and P2 do have the same contents, but their references aren't.
Yep. So I agree with you. First of all, you can see this part over here can definitely support. If the references are equal, the contents are equal because they're comparing the same objects. Do you think 2 is true or false? Do you think 2 holds or does not hold for 2? When we say if the 2 objects are content equal, then they must be the same objects. Must be false. Which line kind of show to you? 7. 6. 6 to 7. Absolutely. Spot on. Okay. So this one here, let me say, very good. So these 2 lines actually support that this one does not hold. And 1 actually holds always. Okay. Let's look at this one just once more. Okay. You can see here, P1 and P2, P1 and P2 over here, let's go backwards. P1 and P2, their contents are the same. Does that imply they are the same objects? Not necessarily, because you can see this, in this case, P1 and P2, they are different objects. Right? Important logical statement for you to remember. All right? If the 2 objects are simply like aliases of each other, means their reference equal, then the contents must be equal because you're comparing the same object. Doesn't matter how you compare that, it will just be true. On the other hand, if 2 objects are content equal, it might just be that their attribute value happen to be the same. But are they the same objects? Not necessarily. Okay. Very important. All right, any question up to now? All right, very good. Why don't you guys get ready for attendance checks, and I want to give you guys credit. The reward. I believe I already refreshed my location, so it should be okay. Start the class. And then the poll. Yeah, guys, don't worry about the question. Just check in. All right. If you got any trouble checking in, please raise your hand. Yeah, so everybody's okay, right? I'll wait for, got trouble? Okay, why don't you come over? Yeah, I'll let you just put on the sheets. That's okay. Just come over. Yeah. Everybody's okay about checking in? Okay, I'm gonna wait for 20 more seconds. Oh, if you got trouble, just come forward, please. Yeah, right away, yeah. Yeah, find your name and just put a signature here. That'll be enough, yeah. can you just put a check mark just right beside here? That'll be good. Thank you. Yep. Thank you. Awesome. Good. Oh, if you can just put a signature, if you don't mind. All right, thank you so much. I'm going to stop it. All right, it's now 9:21 according to my clock. Let's take a 2 minutes break, right? Don't go away until 9:23, and then we'll resume. Okay, you should have raised your hand much earlier, right? Okay. Okay, why don't you put your name here? All right. Yes. You also got trouble with it? Okay, good. Thank you.
Yeah, I did join, but I forgot that. We had to answer the question.
Yeah, you should. Oh, why don't you put your name here?
Okay.
Yeah. Just find your name and then check mark and then put your signature. Just sort it by last name. So what's your last name?
Lucas, no, pull one. D is in. Yeah, okay, I found it.
Okay, can you put a signature here, please? Yeah, thank you. Okay, we'll resume in just one moment. Okay. Okay. All right. I think we should resume. All right. Okay. Right. Okay, that's what we finished just right before the break. And so far, we have talked about just different scenario for the overridden equals. Now, we want to see what will be the corresponding JUnit assertions for checking this, rather than just system that out the print line. That's the only new thing we're going to learn. And it's incredibly easy. You just have to remember assertSame and also assertEquals. And remember I said before, assertEquals should just be for numerical types temporarily. But from now on, you should know how to do assertEquals on reference type. That's something we'll see. Okay? Let's just go over definition. Okay. Let's see this. Okay, let me see which one I want to talk about. Oh, sorry, just one more slide. This one is also easy. Whenever you want to design your equals method, I think these are just some property you want to make sure is satisfied. You want to make sure if you have some context object that equals null, it should always be false. By the way, this logical negation from your math course. Okay? And reflexive, one should be equal to itself. Symmetric, if I say x is equal to y, y should be equal to x. Also obvious. And transitive, x equal y equals z, x should be equal to z. Right? Very straightforward. Right? If you want to find more information, you can go to the API for the equals method. Right? So these are usually criteria to check against your equals definition. But I would say very rarely you actually violate these, but at least you should know what they are. All right, JUnits. And now I want to go over, start with a simple one. Okay? The assertion you may have seen before for sure, assertSame. And the definition is very straightforward. It simply just boils down into expression 1 and expression 2 have the same objects, have the address for the same objects. Okay, so that means expression 1 and expression 2 are aliases of each other. This one here is just equivalent to, it is the case, they are the same address. Or they are not it is not the case, they are the different address, double negation, basically. All right, so this, whenever you see this, you can think about it's equivalent to either this or this. Assert the same, just checking addresses. It doesn't check any equals method just yet. Easy example. Let's say we got P1, P2, and P3. All right. So here we got P1 pointing to some objects, P2 pointing to some objects, And also P3 is going to point to wherever P1 is pointing to. That's the setup, right? assertSame, P1, P3, obviously should pass, all right? That's why I say check mark. And if I say P2, P3 assert the same, no, they are not the same objects, obviously, so that would fail. And of course, obviously, here I'm putting this assertion here after this one. In the actual JUnit test run, if you put this assertion first, it will fail first without reaching this line here, just for your information, right? Okay, that's assertSame, which is pretty straightforward. Now, assertEquals. Let's review what you know already, and then we're going to get into the next page about the different scenario for assertEquals. For expression 1, expression 2, if you just try to remember, this will be expected. This would be somehow like an actual, right? That's what we said before. If you compare these two expressions, if they happen to be primitive type, like integers, in that case, we just compare their value, which is boiled down into just equal, right? Easy example, I and j and assertEquals, 10 and 20, not the same. So it's going to fail. This is what you know already. The next page, we're going to talk about assertEquals applied to the reference type. Right? That's something we just went over. The definition is incredibly simple, but we're going to see many examples to double check. Whenever you say assertEquals expression 1, expression 2, it goes as follows. Expression 1 here dot equals expression 2. Let me be very, very explicit over here. Let me put it down here. Let's say, if I say assertEquals, if I say x and y, this boils down into x dot equals y. And if I say assertEquals, and if I got y and x, you can see I swap the order. That one is going to correspond to y dot equals x. So the first argument here is the context objects. That's something I want to point out explicitly. Does it really make a difference? I would say if x and y are of the same reference type, like a point v2, or they're both point v1, it doesn't make a difference because of symmetry. However, if x and y are of different reference type, then it might make a difference. We'll see some example a little bit later. Okay? So here we are assuming that x and y are reference type. Okay, and then when we compare these two over here, okay, let me be very precise over here. These two may make a difference if x dot get class not equal to y dot get class. Because in this case, we're going to call the version of equals that's defined in x type. In this case, we're going to call the version of equals that's defined in y type. If there are different types, of course, we're going to call different versions. Right? That's scenario number one. May not make a difference. A difference if otherwise. Otherwise simply means x dot get class and y dot get class, they are simply just equal. Right? That's what I meant otherwise. Right? Just make sure this is clear to you. All right? Just remember you got to put the first argument to be the context object for equals. And the second argument would be the actual argument for the equal method. All right? And we're going to do an example. Okay, let's try. And here, if you recall, in point v1, we did not override. In point v2, we did override. Right? Just remember that. right? So let's try. If the equals is simply not explicitly overridden in the expression 1, it would simply boil down into the default version. Let's see how, okay? Let's say we got P1, P2, and P3, all right? Okay, let me draw that quickly, P1, P2, and P3. So P1 is pointing to some point V1 objects. P2 is also pointing to some point V1 objects. And P3 is pointing to some point V2 objects. Right? Let me highlight to emphasize they are different. These are the same. This is different. Right? And then, if I say here, assert equals P1.P2, P1 and P2, it will simply boil down into P1 dot, I'll just say E for short, dot equals P2. And P1 is of type point V1. So we're going to call the default version, which will simply boil down into P1 equals P2. Apparently, P1 equals P2 is going to be false. So that one is going to fail. Right? You can see the reason, because they're different objects, different addresses. And let's just continue, right? What about this one here? If I say P2, P3, this is going to be a little bit different. Maybe, let's see. Here, this will be simply say P2 dot equals P3. That's what we'll get. P2 is of this particular type, also point V1. So it's still going to call the default version. And it will simply boil down into P2 equals P3. And they are not the same objects. Right? Also fail. Are we okay so far? Okay, good. Very good. All right, let's now take a look here. What I want to, let me see if what the difference is. Okay. For the next one, let me focus on this particular line. I think that's a line we want to focus on. The previous one, you can see P1, P2, P2, P3, we have discussed them already, right? I'm going to skip them. Let's focus on the final line over here, okay? Now, let's visualize again. Oh, actually, I think the visualization will just be the same as before, I think, right? Remember, we got P1, P2, P3, P1, P2, and P3. Okay? Now, if I say assert equals P3, P2, which version of the equals method will end up being called? Marcus?
The overridden one.
Why?
Because P2 is like the P3 object.
Exactly, P3. That's the key. Thank you. You can see P3 over here. Of here, right? So it's going to be P3 dot equals P2. And this one here is actually going to compare P3 and P2, right? And if you call the default, call the overridden version to compare P3 and P2, you can see they're simply not the same type of objects. So it's going to fail at this line over here, the get class, right? That's something we discussed earlier, right? For that part, I can let you convince yourself. So it's going to be false. Yeah, exactly. That's what I wrote about get class. All right? And any questions so far about assert equals? Recap. assertSame is going to compare addresses only. Assert equals, it depends on the types of the expression. If we talk about primitive type, assert equals will just compare their value, primitive value. But for reference type, when you see the assert equals, it's going to boil down into the first argument x dot second argument y dot equals second argument y. In that case, which version is going to be called? You have to trace the code to see what dynamic type of the object is. It could be this one here, or it could be this one here, and then see which version is being called. And then tracing will be much easier. Marcus?
So does that mean if you don't have like an overwritten dot equals,
Yeah.
it's basically the same as assertSame?
Yes, that's right. That's a very good observation. Let me write it down. So let's say if I got point V1, P1, point V1, and also point V1, P2. It might be in the slides, but I'll just write it down. It's a very good observation. So if I say P1 dot equals P2, and we know that P1 here has this type, so it's going to call the default version. Boil down into P1 equals P2. And is also equivalent to assertSame, happen to be. Yep. Okay. All right, let's see the next one. Okay, this one has been done. This one has been done. So we just trace more code. Okay, just do more examples. Okay, so let me see 1, 2, 3. And then, okay, how about this? I would suggest the following. We might do this in the beginning of maybe Wednesday just to go over them. But I would like to talk about short circuit evaluation very quickly since I mentioned that early in the class. Okay, why don't we talk about this? But don't really feel afraid to actually go over this part of the code, which is on slide number 14. We got 3 test methods over here, which will exercise about assertSame, assertEquals, and etc. That's something you can also go over. I'm going to highlight certain points you want to watch out for on Wednesday. Okay, but let's now talk about short circuit evaluation. Okay, so short circuit evaluation, right? Can I assume you guys know about the truth table for the AND and also the truth table for the OR? That's something at least I can assume. All right. Let's talk about short circuit evaluation. The idea goes as follows. In order for the conjunction or AND to be true, both of them must be true. If any one of them is false, it's going to be false. That's the insight you want to have about the conjunction, right? And the idea would be if any of the operands is false, the conjunction result is going to give you false. And what does short circuit really means on the conjunction? That means when I try to evaluate, let's say these two, this expression here, something and something. If I already know this evaluate to false, does it really matter what this is? It doesn't. So the short circuit evaluation tells you as follows. It's going to try to evaluate the left-hand side. If it's already false, don't bother with this for efficiency reason. Are we okay with this? Okay. First of all, you want to understand the truth table and then understand the insight. This will only be true for conjunction if both are true. If any one of them is actually false, the overall result will be false anyway, despite what the right-hand side is. In that case, at the runtime, we'll always evaluate the left-hand side of the conjunction. If it's already false, don't bother with this. Okay? Before I talk about this example here, let me go over the symmetric definition for disjunction right away. Similar idea. So this is disjunction. And the insight would be the result for the OR will only be false if both are false. That means if any one of them happen to be true. For example, this can be true, this can be true, or both are true. If any one of them is true, the overall result for the disjunction will just be true. That means if I try to evaluate the disjunction between this and this, I will evaluate this first. If this one is already true, does it really matter what the right-hand side is? It doesn't. Right? Similar thought. Okay, I'll write it down here. So if any one of the operands is true, that means the OR is going to return true. All right? That's a short circuit evaluation. Let's see how that can be used. In some way, the way you want to use the short circuit evaluation, let me just give you some conceptual sketch. Okay, if I got, let's say, some expression E1, E2, and also expression E1, oh, let me use a different one. And also, oh, I said I want to use a different one. E3, oh, E4. There we go. That's what I meant to write. You can think of the left-hand side as so-called guarding condition. Meaning as follows. For this one here, you're trying to guard the E2 over here. And if the guarding condition happens to be false, you don't evaluate E2. Effectively, you are preventing E2 from being evaluated if E1 is already false. Prevented from being evaluated if E1 is false. Symmetrically, this will also be a guarding condition for this, but it's a little bit the opposite. If the guarding condition evaluated to be true, that's going to effectively prevent E4 from being evaluated. Because if this is already true, it doesn't matter what this is. Overall, it will be true anyway. Okay? Let's go over the principle, and then I'm going to show you an example about how it can be used. Prevented from being evaluated if E3, in this case, is true. All right? Let's see examples. Okay, let's talk about conjunction first. I want you to stare at this block of code quickly. Just to set you up, we got input X, input Y, just from the user. I want you to focus on the condition for the if and else over here. Stare at that just for 1 minute. Okay? And I'll be very happy to hear if anyone can volunteer to tell me how the short circuit effect has been applied in this block of code for conjunction. Okay, Farris already raised his hand. I'll call you in just 1 moment. Farris, let us know.
Well, in the first if statement, if you input x as 0, then we won't evaluate the right x side, we won't evaluate y over x.
Mm-hmm.
And if you don't, and you put a number, then we'll evaluate y over x. And if it's greater than 2, we'll execute that statement.
Okay, yeah, very good, very good. This, let me try to elaborate that just slightly. Very good. I want you to look at this expression here. All right? You can think about this part over here is the guarding condition. It's trying to guard the division. We do not want to have division by 0. If you ever do, for example, 5 divided by 0 in Eclipse, you're going to get crash. Okay? So you can think about this one here is the guarding condition for division by 0. Right? Let's see how. Let's talk about this one here. Let's just do this test case. You can do the other one as exercise. Let's say x is 0 and y is 10. Okay? If x is simply 0, that means we got 0. I'll put it here. We basically got 0 not equal to 0, and y would be 10 divided by 0 larger than 2. Right? That's basically what we're going to evaluate. However, at the runtime, we are not going to evaluate both of them because this part over here is already going to be false. So we don't really even bother with the right-hand side. That's really what a short circuit can be used for. Okay? This part over here is already going to be false. And this part over here, not to be evaluated, which is good. Are we okay about this? This one example. I have a question for you right away. The same block of code. And what I want to do is this. I want to switch. Rather than this, what if I say y divided by x larger than 2? And the right-hand side, logically speaking, they are the same. Because when you say P and Q is equivalent to Q and P, right? Logically speaking. But is this code going to reach the same effects for the same input? Let's say x is equal to 0, and I believe the one is y is equal to 10. So here's my question for you. Is the short circuit effect going to help us in this case, given that we swap the order of the operands? You want to somehow follow the same principle. You always evaluate the left operand first, and then the right operand, if necessary. So now in this case, are we going to get a crash or not? We are going to get a crash, right? I'm pretty sure you agree. Because in this way, we're still going to evaluate this first. And then we're going to crash because of division by 0. Right? So the order really matters for the short circuit evaluation. Right? That kind of answered your question, I guess, in the beginning, right? Yeah. Good. Awesome. If you give me just 1 or 2 minutes, I want to just finish the part about disjunction very quickly for completeness. All right? The same example, but now I just write the condition a little bit differently. Okay? I still want to guard, I still want to protect the division by 0. I don't want this to be evaluated if I got the possibility of division by 0. So the way I write it, because I'm now using OR, is a little bit different. So if you take a look at it here, x equals 0 here, right? I'm saying that if this evaluate to be true, short circuit effect tells me for disjunction, if this is already true, it doesn't matter what this is. So that one is not going to be evaluated, right? If true, the right-hand side will be skipped. Let's do one example very quickly. Okay? Let's say we got this one here. X equal to 0 and y equals 10. Okay? X, so that means this will boil down into, let's instantiate the expression here. So we got 0 equals 0, or 10 divided by 0 larger than 2. Now, in this case, you can see this part here evaluate to true. And for disjunction, if this is already true, not to be evaluated. All right, that's short circuit effect applied on the disjunction case. And of course, easy exercise for you. If I swap the order of these two, are they going to work? They're not going to work for the similar reason. I got 2 exercises for you. Let me write them down, and then we're done. Okay? Exercise number 1. Swap the order of these two. Swap the order of these two. All right? Exercise number 2. Compare the short circuit evaluation condition between conjunction and disjunction. What do I mean? Specifically, for the case of disjunction, we put x equals 0. But for conjunction, we put x not equal to 0. Convince yourself it is actually right. We already traced the code without input, but you want to convince yourself why. In this case, it would be not equal to. But in this case, it would be equal to. Right? In the test, I might just put some arbitrary order of the expression and ask you whether it's going to crash or it can be guarded properly by short circuit effects. And also, by using either this or conjunction, the guarding condition may have to be phrased slightly differently. That's something I want you to think about. All right? Guys, thank you so much. And I'll see you on Wednesday, and then we'll definitely finish the lecture.